Hello and welcome to my workshop. Today we're going to continue with the laser theme, and I'm going to give you a little bit of information. If you are considering on purchasing a laser to do 3D carving to make a product or to sell a product, forget about it, because you're just not going to do it. You certainly won't make a profit, and the reproduction of a 3D carving in a laser is very complex and very time consuming. If you're interested in 3D carving, you need a CNC router. This is an example of my personal CNC router, and it will turn out perfect 3D carvings like this group of horses and many others that you'll see dotted around my workshop, and indeed already published on my YouTube channel. Etching with a laser is not sustainable. It's not really sustainable at all. You can do it, yes, but the reproduction requires a lot of finishing work. The materials that you can etch into, I mean, this is MDF. Okay, that's fairly clean, but it's not a very good material. And if you notice this one here, this is Tasmanian pine. Wood isn't, the structure of wood then isn't consistent. You have soft areas, and where you see these darker lines, the material's harder. So if you notice, if the camera's picking that up, you get these raised areas that the laser can't burn through at a given power level. And if you set the power level to actually burn these raised areas, the soft areas will be lower again, so you still have this ribbing effect. Now I've found that hewn pine, now that's a relatively hard wood, although it's fairly light. You know, not a very good example at all, is it? And that is after, let me see, I think that was 5 or 6 actual cuts. You do it in layers. I mean, I probably could have continued and done 8 to 10 cuts with this at varying levels, and then finishing with a very light level to clean it up. But just to do this small one, you're looking at, you know, 3-4 hours. Then you've got to finish it by hand, clean all this muck up. So I'm not even going to do a video showing you the process of this, because I don't believe in it. And if I don't believe in something, then I'm just not going to video it. It's just not worth the process. At this stage anyway. So if you notice, next to this partial 3D carving, this is a very good carving, and it's about just over 1 millimeter deep, and it's done with one pass of the laser, and it's not burnt. It's a good carving. This is a 2.5D carving. what's regarded as 2.5D. So what we're going to do today, we're going to do a project which can be part of your product line. So it's another product to go on your product line. So what we're going to do is we're going to design it all in laser cut 6.1, and then we'll cut it out on the laser, and as we're designing it I will explain which individual part is, and we'll take it from there. Okay, so when you design a product, you know, you start off with, I've got a piece of glass here which is about 1.5 millimeters thick, and it's 210 millimeters, which is 8.25 inches by 295, which is 11.75 inches. So we're going to make a picture frame that is, this is going to be incorporated, so everything is measured from this. So I'm going to quickly show you the process now of designing directly in laser cut. And this is a very, very simple thing to design. So you just start up here and you choose rectangle, and you just come anywhere in the drawing area, it really doesn't matter, and just click once, draw out, click again, then go to the highlight tool, change the highlight tool, come to one side, right click, and then go to size. Now in our case we need the open area, alright, or the cutout area, to be slightly smaller than this. Okay, so we're going to make it about 5 millimeters or so smaller all the way around, so the glass doesn't fall through. So in this case it's going to be 25 by 200. So in the X, which is this way, it's going to be 200. So by the way, undo this and check that, because otherwise if you alter the one, the other one will correspondingly alter with it. It will alter the aspect ratio. Okay, so in X we want 200, and in the Y we want 285. I press OK, and now it's gone to the right size. So it's at this point now where we want to align it. Well, actually it's okay where it is there. So the next square or rectangle, which is going to be the outer part, we're going to give it about a 45 millimeter all the way around area around for the frame. So it's going to be 300 by 400. So we just need to move the outer square down now. We still have it selected, and we can do that with the arrow buttons on our keyboard. So the next thing we're going to do now is we're going to choose some art and bring it in. Now what I thought was I'd just have a small design on each corner here and the top as well. So that's what we'll do now, is get some art. Okay, I like this. This is a very nice, simple, a silhouette, I would have thought you would have called this, drawing. So we're going to use this one, so we're going to treat this one. Now, at the moment this is a JPEG. The computer won't understand that. Not the computer, but the laser won't understand it. So we have to now change this to something the laser will understand. We use a very simple program, which is a free program again. This is a Windows utility. It's called Paint. Free to everybody. All we simply have to do to this one is drag and drop it in, and resave it as a bitmap. That's what a laser understands, bitmaps. Okay, that's that one. I think actually we'll do another one as well. I'll keep the theme with butterflies, and very simply again we save this one as a bitmap and import on the desktop. So that's too big, so we put some handles around it or highlight it and then resize that. Now in this case we want the aspect ratio to be selected. So if we say we want this possibly 60mm wide, say 65mm wide, and let's just see how that fits on the corner. I think that's good. Now we've made this a size that we need, I need to make 4 copies of that. So to do that you come over here, so we want to make, okay, 2 this way, 2 in the Y, 2 in the X. Now you've got to put a gap in between them, so 5mm gap in the Y and a 5mm gap in the X, and go, we have our 4. Okay, so we've got our 4 now, so what we need to do is invert them and make them the right way around. So this one we need to make a mirror image, so we just come up here to draw and select that one, makes a mirror image. So we bring this one here now, and you can get it pretty exact. So this one we have to do 2 operations. We have to do that way around and invert it like that. So you can build up a picture very quickly and easily. So now we'll bring in our second picture. I thought we'd have this one on this side, one on that side, because otherwise it's a big area to have nothing at all. Don't worry about whether this is overlapping any of our lines, because it's going to be on its own separate layer. So basically our design is done. Now our frame is going to be made up of 4 individual parts. Now this is the main frame that's going to be cut out of ply. Okay, so we have to put this onto separate layers, and whatever the order in which they appear up in this listing up here, that's what the laser will cut. So the top one will be the first thing the laser cuts, and so on and so on. So we have to, in our mind, consider, okay, what needs to be first? So the etching needs to be first. So we're going to leave that on a black layer. So then what we're going to do, we're going to highlight this one, because it's the inner part we want to cut out first after the etching. So that is going to go on a blue layer. And then the third and final operation is to cut the whole thing out. So then select this one, and that's going to go on a red layer. So you understand? You have to sort of have some forethought of, okay, well I want to do the etching first, because it's all going to be one piece, Then I'm going to want to cut the center part out, because that can drop out and away and it doesn't matter. Then the last thing, I want to cut the whole frame part, finished part out. So we're going to set this up now. We're going to go back to the first layer. No, we don't want that yet. Okay. It's an engraving layer, so you change it to engraving. And I want this to be a fairly deep engraving. And I want sort of a very nice, neat engraving. I don't want to see any scan lines whatsoever. So to do that, 400, I'm going to set that at 300. That's 300 millimeters, so that's virtually 12 inches per second of travel of the laser. Bidirectional, so we're going to cut both directions. Engrave, blowing, always have the blowing on, whether you're engraving or cutting. Because if it's not there to evacuate the smoke and debris and gas, while we're talking about that, a lot of people have this misconception that a laser isn't dangerous. Well, it is. Whatever you have inside your laser, whether it be a piece of wood or plastic, especially plastic, the laser isn't necessarily burning it. That is part of the process. It is changing that material. When the laser hits that material, it's such a violent thing and such a huge amount of energy in such a small space on the material, it immediately or instantly changes it from a solid to gas. Now, unless you have a filtration system filtering out the particulates, you know, it's dangerous. It's carcinogenic. So if you're in a workshop, you know, I mean, you just don't vent it straight outside, because then you're pumping those gases into the atmosphere. So it's very, very necessary for you to have a filtration system for your own safety as well as others. Okay, having said that, I know with this machine it's 200 watt laser, so it only requires relatively low power to carry this out. Now, as I've said in other videos, although we're saying 20% and 35%, that doesn't give you 20 and 35 watts. That gives you about 35 watts and about 45 watts, because it's not a linear scale. Okay, I have gone into that in earlier videos, so go back and have a look at some of my earlier videos. Okay, so these are set right because the last job just happened to be an etching that I was doing. Now this is they call it scan gap, but it's the step over. Each time the laser makes a pass in the X, it will step over or move, progress in the Y, this measured amount. So this is, in this case, it's 0.09. Now that's, in earlier videos I have shown you demonstrations and explained how this comes about. I've got a 2.5 inch lens. Now you would think that the spot size would be 0.2 of a millimeter. Well, it's not, depending on what speed you're traveling. The faster you travel, the spot size gets smaller. because of the shape of the energy shape of the laser as it hits the material. I've talked about that in other videos too. So you have to have this knowledge behind you before you can do these things successfully. So I urge you to go and have a look at my other videos. Okay, top down is Chinglish for bottom up. In other words, it'll start cutting down the bottom here or etching down the bottom here and work its way back, which is preferable because the airflow is going that direction. Okay? So we're going to say this is all good and there's nothing else to fill in here. This is only necessary to be filled in that if you had a full sheet on here and you're in the home position with the machine, in my machine the home position is in this back corner here. If you wanted a particular spot where you wanted to come and cut out on the sheet, then you would fill this XY coordinate in. But in our case we're going to set the 0, 0. Okay, the start of the program, which is indicated by this little yellow box here. We're going to set it actually on the material. Okay, so we're going to calculate that. And it's calculated. Very quick computer, this one. Okay, so the next thing we want to do is cut that center piece out, which is on the blue layer. Okay, now the material we're going to be using for the frame is going to be, let me see how thick it is. It's plywood and it's 8.5mm thick. Okay. Now you will see in earlier videos, one of the first videos I did, that I cut these out where I was chasing the correct cut-in, feed and power rate to find out which was the best and the quickest, because it's all about speed as well, way to cut this out successfully. And in the case of my 100-watt laser, it works out 24 millimeters per second cutting speed at 85%, and very, very clean cut. See, no burning, just a very, very clean cut. And so, you know, this is what we're going to be using. These are what's called telltales. So you do a test with your laser to find out, you know, which is the best for a particular material to cut it or etch it. So you make these storyboards. So you keep them then as a reference. So when you come to this material again, you know exactly what to put in here. So that's what we're going to do now. Oh, and incidentally, not every time you use a laser, I suppose it depends on what you are cutting in it. Every couple of days or every couple of uses that you use your laser, clean your mirrors, because if you don't clean your mirrors, these figures will alter. You know, you can lose, you know, 5–10% just by having grubby mirrors. So clean your mirrors. Now when you're cutting, what I'm going to do is I'm going to step this up to 90. Now I know at 90% is 100 watts. Now that'll push the laser straight through the material immediately. So you need to sort of cut a hole, the initial hole in the material, you need high power as quickly as you can. So this is like striking the arc then, as it were. because it's going to immediately punch a hole through. So we're going to go maximum power of 90, and again in the corners, okay, because this thing's called beam drag, and there's some delay from the laser changing direction. It can hang up in the corners, so you give it an extra belt in the corners. I'm just going to do 88 there. That'll do for that. And 85. So you set blowing 1 and blowing 2. When you cut it, you set it the same percentage. You don't want any variation there. Always blow it, and we calculate that. Okay. And the same for this one. And it's as quick as that. We've made the main part of our product. And in real terms, you know, you can do this in 5 minutes. Okay, I've just quickly drawn the stepping out part that the picture is going to slide. Picture on the glass is going to slide down into. So now I want to draw an angled piece that is going to be stuck on the back to hold the picture up at an angle. It's just simply line drawing. It's as simple as that. Put that on a black layer. This is going to be put on a blue layer. Now for our last part, which is the panel that goes onto the back of this, gets glued onto the back. Okay, now you can move these around by the arrow keys on your keyboard. So, now I like to leave between a 3 and a 5mm gap, because otherwise the material warps and you can take it out of focus slightly. So just leave yourself a good gap. And that one we're going to put on a red layer. So these 3 parts are all going to be made of the same thin gauge material, which is a 3.5mm ply. So now then, the first piece we need to cut out is this one, which is on the black layer, which indeed is correct, but we need to have it cut in. Okay, 24mm a second, fine. With this we're going to go 50, corner 50, and we're going to go 45 and 45. Grave blow in, everything there is okay, and we're going to say okay. Blue layer, which can be the next one to be cut out. 24, 50, 50, 45, 45, that's okay, that can be cut. And the last layer, 24, 50, 50, 45, 45, and that can be cut in that order. So we're getting 3 parts out of the same material, and the only part that is going to be sort of, well, not really wasted, because this part can be, you know, we could cut a second one of these out if we wanted to. So you know, you use the minimum material that you can. Okay, so that can now be saved, and next thing is we'll go to the laser and get this job done. Okay, we've got our piece of material now set up squarely on the table there. I've got the program set into the computer, and I just want to point out one thing to you. When buying material for your laser. It needs to be flat. Now, it's the first piece of material I picked up. Can you see down there? It's warped like a banana. It's totally useless for a larger job like this. It's going to be 400 long, because if we set the laser height, the Z height here, which is 9.5 millimeters above the material, and it has to be plus or minus a millimeter, you know, it's fairly precise. By the time we get here, it's only going to be 3 millimeters above the material. It's going to be totally out of focus. So when we're doing our etching, it's going to look not very nice. So it's going to take it out of focus. So, I mean, for smaller jobs, this piece is fine. But for larger jobs, you know, it needs to be totally flat. And I'm lucky I have a flat piece. So, here we go. So now we'll start the laser up and load this up to the laser, and we'll start the etching. So now I'm going to set the start of the program somewhere about here. So that means we're going to set the Z height. So we'll lower the Z first. Just an amount. Now we'll bring the head over to this plate. Okay, now we'll set the Z height. So now we'll set the XY 00, start of the program. I don't want to go right out to the edge of the material because there is some rough pieces. That'll do there. So I'm just going to run a test now around to see if it all goes on there. And you could tell by running around whether the material is warped or not too, by whether this laser spot actually changes in relation to the end of the nozzle. Let's just do that again. So you can see that the spot is very stationary in relation to the end of the nozzle, so we know that this is pretty well flat. So okay, so we'll start the process now of etching and cutting out, and I will use fast photography or high-speed photography for this and play you some nice music. And you couldn't get a more fitting photograph to put in a nice delicate frame like this. So this is another product that can be part of your product line. Now, you can probably make somewhere in the region of 30 to 40 of these a day. Not everybody is going to want to buy a little vase or a photograph, you know, etched in glass or wood or paper, but you need a variety of items in your arsenal, and a laser is a good start. So what I would suggest for rapid production of these type of items, this type of laser, 100 watt, industrial, not a 50 or 60 watt toy that you can get for $1,000. This is $6,000 worth, plus with a good recce 100 watt tube in it. Go and have a look at 207, my video 207. I go into great detail about this particular laser, and in particular the tube that's in it, the actual laser tube. It's information that you need to know if you're going to buy your own machine from a manufacturer. So the laser is a good starting point. Another good starting point is a CNC router. Now that is going to be the subject of our next video, where I go into 3D engraving, where I show you how to perform 3D engraving with a CNC router, a 6090. And I will explain to you about CNC routers and the things to look for if you intend on purchasing one for yourself, because it's a minefield out there, and you can buy a machine that you will not be happy with, and it will not perform like you see my machines performing. So that'll be the subject of the next video. So for this video, it's quite possible with this sort of item to make $2,000 a day, between $1,500 and $2,000 a day. You don't have to use plywood. You can use teak if you wish, expensive wood or hewn pine. And I will be doing that in the future. So thank you for watching this video today, and don't forget to like and subscribe. That helps the channel a lot, and pass it on to your friends if you like the video. Combined on my channels now, there's nearly 400 videos, so you've got plenty to choose from, between lasers, CNC routers, CNC milling, wood turning. I do a lot of wood turning, and I will be getting back to that in the near future as well, and different shop jobs I do around here, a bit of furniture making, and a bit of 3D printing as well, all sorts. All these machines really are CNC machines. This is a CNC machine, CNC router is a CNC machine, computer operated. And of course all the associated programs with the CNCs. I also now do tuition on Fusion 360. Now I'll tell you a little secret about Fusion 360 that not many people know. Now there's been a lot of complaints, I've had people complaining to me that, oh, they've discontinued ArtCAM. What do you suggest we buy? What can we? Well, all the tools that were in ArtCAM are in Fusion 360, and in a couple of videos from now, probably after Easter, I will show you them, and I'll show you how to operate them. So ArtCAM really isn't dead. it's hiding in Fusion 360. And actually, if you are a hobbyist or a teacher, or if you run a business, new start business, and you're earning under I think it's 100,000 a year. Don't quote me on that figure. You'd have to check with Autodesk. The program is entirely free. So the old ArtCAM program that is built into Fusion 360 is now free. So go along to the Autodesk website. There's a link below. Download Fusion 360 and you give it a try yourself. So thank you for joining me, and until the next video, it's bye for now.